Yeah, no, not really plug and chug. So one of the most important properties of a tangent line is that that line that's tangent to the circle will be perpendicular to the radius drawn to the point of tangency. Which means in problem 1, since segment ED is my tangent line and segment OD is the radius drawn to the point of tangency, I have a right angle here. Which makes it wildly, ridiculously easy now to find the value of x, because of course this uses a fact that's tattooed on your soul, that the three angles of a triangle add up to 180. Thank you. Tattooed on someone's soul. So 90 plus 38 is 128. Subtract that from 180, and we get 52. There's a your turn that uses the same property on the next screen. It will be a Centillo question. However, if you are already looking ahead at it, you may notice, but Mrs. Clouse, that's not a triangle. And you're right, it's a quadrilateral. So its angles don't add up to 180. They add up to 360. That's what you're using. Wildly easy stuff. It's a multiple choice Centillo question. There's more than 9 of you here. Please make sure you're logging Centillo on. And when you find your answer, please select the choice that represents your answer. In this problem, segment AD and AG are tangent to the circle. Points D and G would be my points of tangency. That means those are my right angles. And I see, oh, good, we're starting to log in now. Answers are starting to come in more quickly. Let's wrap it up, please. As always, if you're just waiting for us to catch up to you, you know what's coming up next. It's in your notes. You could look ahead. Wonderful. Overwhelmingly, the correct answer was the selected answer. Just in case you selected the right answer because your neighbor told you, but you're not quite seeing it, or you are that one that I am not at all interested in shaming. Let's talk about this. I overheard some wonderful things. You realized, as we discussed, that these 4 angles have to add up to 360. I kind of paved the way for you and nudged you in the right direction and showed you that those angles are 90 degrees. And from there, it's just 180, 2 90s put together, plus 152 subtracted from 360. And that gives you A as the correct answer. And as you can see in your notes, that's that level 2 skill. Being able to know enough about these tangent lines, know that there's a 90-degree angle, and be able to use that to find an angle measure. The bulk of our lesson, however, has to do with using tangent lines to find segment length, which you see right there in skill level 3. So in problem 2, we have Jasmine riding in an airplane, and you ever notice when you're in an airplane you can see a whole lot more Earth than you can when you're just standing on the ground? Because that tangent line between your eyes and the horizon is just that much longer. So realize what's happening in this problem. Here's the Earth. Here's Jasmine, 6.5 miles above the Earth. And in the airplane, she can see to that point of tangency. It tells us that the Earth's radius is about 4,000 miles. And they're asking us, how much Earth can she see? Just like I mentioned previously, that tangent line is perpendicular to the radius drawn to the point of tangency. So our right angle is here. How am I going to find how much Earth Jasmine can see? Say it again.
Did you hear a squared plus b squared?
Pythagorean theorem, absolutely. We have a right triangle. We know two of the lengths. We use Pythagorean theorem to find the third. So our Pythagorean theorem, whoops, that's... They're not ears, they're radar. Okay, so 4,000 squared plus x squared equals, what's the length of the hypotenuse? 4,006.5, yes. And that's the Pythagorean theorem that you're plugging into your calculator. And to the nearest mile, I have that she can see 228 miles. And once again, if you're kind of glancing ahead at the next few problems, you might be realizing that Pythagorean theorem plays a huge role in this lesson.
That's easy.
Until you get to the back.
Yeah, there's some.
But it's not difficult, it just, you have to be really careful. We have from the screen what we need. Not yet. As always. Are we okay?
No, I'm not okay.
Okay. Are you looking ahead at the next problem and not liking it? Oh, yeah. Yes, ma'am. Absolutely. And actually, Haley, thank you for bringing that up. I said earlier that you need to be at level 3 in order to demonstrate mastery of this topic. And some of you looked at that description of learning. I see Kristen in a second. And you saw that in level 4, it says the word prove. That's level 4. That's above and beyond. Okay? If you can do level 3, you know what you need. Kristen, question. All right, so you have a scientific calculator. Easiest way to type this into your calculator without having to clear anything out. First of all, looking at that black equation on the screen, do you see that since I have 4,000 squared plus x squared, somewhere in my calculations I'm going to have to subtract that 4,000 squared from both sides of the equation, okay? So in my calculator, what I typed in was the 4,006.5 squared, and then minus 4,000 squared. Don't forget to hit equals. And then take the square root of that. And we're good? So on to some more Pythagorean theorem. When you plug this in, you have x squared plus 24 squared equals, oh my, x plus 18 squared. Now I'm going to warn you of the mistake that would most commonly get made. Please remember, x plus 18 quantity squared is not x squared plus 324. You can't just square the x and square the 18 and be done with it. Remember what it means to square something. It means that you're taking something and multiplying it by itself. You look at these two binomials right next to each other, and what clean four-letter word do you think of? FOIL. First, outer, inner, last. Remember your algebra? Come back to haunt you. First, I'm clarifying. First times first gives me x squared. Outer is x times 18, that gives me 18x. Inner gives me another 18x. So when I combine those like terms, I get 36x. And then 18 times 18 does give me the 324 that you previously anticipated. And then I just simplify the left-hand side, and I have x squared plus 576. And some of you might be looking at this equation and thinking, oh, I hate quadratics. Well, you're going to see them again in Algebra 2 next year. But the good news is, look at this equation. Something fantastically convenient is about to happen. Say that again, Haley. The x squareds cancel out, and I'm just left with a nice, pretty linear equation. So 576 equals 36x plus 324. 36x is 252. So x is 7. Excellent question. I was asked that previously. I looked already at your homework assignment, and I don't see anything where the x squareds don't cancel. Now, tomorrow is a workbook day, and I haven't looked at the workbook problems, so I'm not making any promises about those. Do remember, please, to bring your workbooks. Yes, ma'am.
Is that how you would set it up every time you get a problem like that? That's like the formula for setting it up?
What you have to realize here, Kristen, is it's just a right triangle. A squared plus b squared equals c squared. What's weird about this triangle is that my c, my hypotenuse, I don't know the whole length. I know, ladies, I know that it's 2 parts, so I add the 2 parts together. Okay. There's a your turn just like it. It's a Centio question. I'm telling you right now, your answer will be a decimal. So when you get that decimal answer, please round it to the nearest 10 before keying it into Centio. Please round to the nearest 10. Again, when you have your answer, please round to the nearest 10th before keying it into the Centio. Okay, in the interest of moving things along. On the screen, gentlemen and ladies, on the screen we see that 5.3 was the correct answer. If you entered 5.33, your heart was in the right place, you just didn't follow the instructions. You still know what you're doing, so you're good. I can see where someone would have gotten the 8 if you did x squared plus 6 squared equals 10 squared, kind of just plugged the numbers in the wrong way. You would have gotten 8. Let me once again show you how you would have plugged it in the right way to get the right answer. The Pythagorean theorem that you're plugging in is x squared plus 10 squared equals x plus 6 squared. Remember, you must FOIL that out on the right-hand side, ladies. You have to FOIL it out on the right-hand side. So you would get x squared plus 12x plus 36 equals x squared plus 100. Once again, conveniently, my x squared terms cancel out. And when I subtract 36 from both sides, I have 64 equals 12x, and that's why x equaled 5.3 root 3. We have from here what we need? Not yet. Okay. In problem 4 of our notes, first of all, I'm very displeased, ladies. I'm very displeased with the way that they have that diagram labeled. They have the 13 in a place where you're kind of, well, is it just that part or is it the whole thing? I'm going to tell you it's the whole thing. I'm also going to tell you on the problems in your textbook, like this problem, the number that they're giving you is appropriately placed. It's right in the middle of the segment, so it is referring to the whole segment. All right, so in this problem, unlike the last few problems, in this problem, I'm not trying to solve for a missing segment length. What I'm being asked is simply a yes or no question. Is this segment tangent to the circle? In the previous problems, I knew that the segment was tangent and I was using that to solve for a missing segment. What am I doing here? Pretty much the opposite, but I'm still using the same principle. I'm using the fact that if it was tangent, then what kind of triangle would MNP have to be? A right triangle. So what we're doing basically boils down to checking whether it's a right triangle by plugging the numbers into Pythagorean theorem and seeing if it works. So let me put a question mark up here because that's what we're checking for. We're checking if 5 squared plus 12 squared equals 13 squared. And as it turns out, it does. So our answer is yes. As far as an explanation goes, since the instructions say explain, the work that we showed was adequate explanation. That's all you would do. It's a yes or no question. You're plugging the numbers into Pythagorean theorem to see if it works.
Is P a right triangle?
If MN was tangent, then angle N would be my right angle. And since it's impossible for a triangle to have two right angles, you look like you just answered your own question. Okay. Have what we need from here. Okay. The last property of a tangent segment has to do with segments being congruent. And before we get into problem 5, if you need a completely separate diagram from a problem in order to process new information, here's the diagram as well drawn as I can get it since my screen is not cooperating. There's my point. And there's my point. What this property says is if I have two tangent segments from the same exterior point, those two tangent segments will end up being congruent. So in problem 5, since circle S is inscribed in this triangle, what that means is that it is tangent to all 3 sides. So you might see L as a common exterior point. M is a common exterior point. N is a common exterior point. And what I mean by that is, I'm going to tell you the first one, and then you're going to be like, oh, I see the other 2. LR is congruent to LO. So I know the length of LO is 8. So, Benjamin, what do you see? The length of NT will be 5. And someone else, the length of MT will be 14. And since this problem is asking me for the perimeter of the triangle, all I have to do is add everything all the way around. So that's 16, 30, 40, 54 units. In the your turn problem like this, the same idea, except this time you're given the perimeter, and you're asked to use that to find a missing side length. We have what we need from this screen. That's all the problem was asking us for. And when you find the length of segment QY, please key that length into your centio. I love it. I'm seeing 2 different ways of approaching the problem and ending up in the same place. You treat this as an equation where there's an unknown that shows up twice. Or you can treat this as a straight calculator problem where you're starting with the perimeter and subtracting things away. There is a daily quiz on Socrative. I think it's already activated. And if you get in the first question, it says, do I know? So we'll check mark there so you know that you know. Okay, still waiting for a few of you with the centio question. Please finish the centio question before you go into Socrative to do the daily quiz. Okay, still waiting for a couple of you on the centio question. Thank you. How lovely is that? Most of you saw the 12. 94, really know where that would have come from. The 15, you may have thought it was congruent to the wrong segment. If, again, you keyed in the right answer because your neighbor told you, or you keyed in the wrong answer, you don't know how to do this on your own. Because of these tangent segments, if PX is 15, so is PZ. And if RZ is 17, then so is RY. You know everything is supposed to add up to 88, so one way that I saw a lot of you doing this in your calculator is starting with the perimeter of 88 and subtracting away 15, subtracting away 15, subtracting away 17, subtracting away 17, And then dividing by 2, because there's 2 of those segments there. Stephanie, question? Of course. And once again, there's a daily quiz on Socrative. Make sure you're logging on and doing that.